Hello, everybody, and welcome to another episode of the TWIS Podcast broadcast. We are here to talk about all the science that we wanted to bring tonight. Woo! It's going to be so very sciencey. Justin, are you ready?
I am always ready. Absolutely.
So very, very. I want to remind you all that right now is the time that gets edited out. There are lots of times that might get edited out in the course of broadcasting this live production of This Week in Science. We say things sometimes we don't mean. I don't know. Rachel edits them out. Sometimes she doesn't, whether or not we mean them. Sometimes there's troubleshooting. Sometimes that goes away. The podcast is the place to go if you want to find all of it edited again and again and again for your listening pleasure. But really, the content is all here. So we're glad you're here watching live. Share, like, subscribe, raw now for all those algorithmic love heart things. Anyway, it's time for the show. Yeah, you know? Let's begin the begin, everybody. It is ready to broadcast the This Week in Science in 3, 2. This is TWIS. This Week in Science, episode number 979, recorded on Wednesday, July 24th, 2024. Is this tractor beam hope? I'm Dr. Kiki, and tonight on This Week in Science, I hope that we will pull you right along and fill your head with some gestures, tractor beams, and false memories. But first,
Disclaimer. The following program contains information that may cause listeners to become more aware of the world around them. While this awareness can be uncomfortable at times, ignorance also has its drawbacks. Considering that the world is constantly an evolving place, physiologically, socially, and through technology, change is normal. And knowing is always better than not knowing. So let's do the smart thing and learn about what's going on this week in science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
and a good science to you too, Justin, and everyone out there. I was about to say Blair, but she's not here. I totally tripped myself up. Welcome, everyone, to another episode of This Week in Science. We are back for another week full of science fun. We have so many stories ahead to talk with you about. I brought stories tonight. Yes, about tractor beams. Little tractor beams, static butterflies, chimp hand gestures. We got them from somewhere. Some dark oxygen, cuttlefish memories. Cuddle a fish, and the memories are right there. And oh yeah, a still suit in real life, maybe. We'll see. What'd you bring,
I don't
Justin?
know what is this still suit. I've got global record hotness. Ancient Argentinians, cow flu update,
Oh no.
and regeneration genes.
Zoop, 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 zoop. Okay, I need to stop hyping up.
Hype noises.
I'm doing
She's
little hype
making-
noises.
She's making hype noises behind everything for the rest of the show. I think that could be a good show.
Oh, what do you do, Kiki? Well, yeah, I do this podcast and I make hype noises. I'm a science hype noise person. Yeah. Oh my goodness. All right, everybody. We have a good show ahead for you, and I do hope that you will enjoy all of it. Make sure that you share, you like, you subscribe wherever you are, because the more people are listening to TWIS, the further it's shared. No, not shared. Shared. The further it's shared, the more that we can really really share with the world our view of just uncertainty and the fact that curiosity and uncertainty are not bad things. And let's keep doing that, okay, everybody? The world doesn't have to be all certainties all the time. Let's have fun with it. We do broadcast this show every Wednesday evening, 8 p.m.-ish Pacific time. And if you're in the Denmark time, it's like 5 a.m. or something like that right now. It'll
Central
change.
European, 5
Yeah.
a.m.
It'll change.
And it's the next day. It's
Time
Thursday.
change. Yeah. Right.
Somehow
Okay,
I'm
not
living
Wednesday.
in the future.
In the future. You're so far in the future. Oh my gosh. Yes, we do this. Facebook, YouTube, Twitch, and we also have a podcast that is all over the place if you look for This Week in Science. And I do hope that you look for us, you subscribe, share, and do all the wonderful things to get This Week in Science in the hands and the heads of all the people we know. Okay, so people sharing science with people, let's talk about dark oxygen, which I think I've talked about on this show before.
I'm going to make hypey sounds. What?
There you
Dark
go.
oxygen.
What? What's happening here? Oh my gosh. Would it surprise you if I said not just dark oxygen, but let's talk about what is the term that they've got here? It's seafloor nodules, metallo whatever nodules, I don't know. Abyssal nodule. There's some great words here.
Mm.
Dark oxygen production at the abyssal seafloor. What does that mean? The deep bottom of the ocean has polymetallic nodule coverings, which I love. Polymetallic, more than one metal in groupings together. And these polymetallic nodules are places that are capable of producing oxygen. It's not just little bacteria in the oxygen in the ocean that are capable of producing oxygen. The seafloor does it as well. And these researchers publishing in Nature just this last week, a brief communication in Nature Geoscience, have published their results looking at in situ oxygen microprofiling of the narrow ocean resources license area of the Clarion-Clipperton zone, where these polymetallic nodules cover the abyssal seafloor. That's the bottom of the ocean. It's the bottom. They used different treatments: dead algal biomass, dissolved inorganic carbon, ammonium, cold filtered surface seawater, and they looked to see what happened. What happens when these things, so like dead algal biomass, when something falls to the bottom of the ocean, what happens to the bottom of the ocean? What goes on there? What happens when you have an infiltration of surface seawater from, the surface to the seafloor? And they found that there was more oxygen accumulating than was being consumed in their experiments. So this means that there is net oxygen production at the seafloor. Yes. This also supports the idea that there was a large amount of oxygen production going on the planet, potentially at the time or prior to the time that that algae and photosynthesizing microbes actually started doing their job of giving us oxygen, filling the oceans and the atmospheres with oxygen. So the question now is, these polymetallic seafloor areas, they're great. They've got this oxygen production. They have these incredible electrogenic potentials. They've got a lot of stuff going on. Additionally, they're usually in areas where there's a lot of sea life and there's a lot of cool things happening, deep vents, the hot smokers, lots of life going, whether or not it's microbial or other life forms. The question now, though, is that we are allowing, or going to be allowing, a lot more mining of our sea floors in the search
We are?
for,
Why?
yeah, in the search for
Oh.
compounds to feed our need for batteries and computer components. Yes. A lot of these substances that are in the polymetallic nodules are also ripe for mining. So the question is, how do we manage this? Do we just let companies go ahead and mine? We've talked about this previously on the show. There is not a real regulation of mining on the seafloors at this point, but it has the potential for really disrupting sustainability of a lot of things in our ecosystem, our limited
Very,
closed ecosystem of our planet, right?
very human-like thing to do.
Yeah. Very human. Why? Why is this so human-like of us? I don't understand.
It's how we roll. It's what we do.
It's what we do. It's just hang. Yeah. I don't know. I do love though the idea that moving on from research that has suggested for a long time that there is oxygen being produced in these areas on the floor, that there's anaerobic and chemical production of oxygen, not just photosynthetic production of oxygen on the planet, that the seafloors are important for this. This kind of evidence is really it's important for us to be looking at and considering how it plays into the overall scheme of oxygen production on the planet and the balance of where our conservation efforts should lie. But it's also just fascinating. Dark oxygen. I think it's anaerobic. It's oxygen being produced from chemical means as opposed to photosynthetic.
Yeah, but do we really need all this oxygen? Is it something that
Need
we
some of it.
use on a regular basis as a well?
Yeah, we need it. I mean, we
I
don't
think
want
we
to
do.
like
I think we do.
we don't need what to like over rust ourselves, but still, it's important. It's very important.
Gosh.
You want to bring me some uplifting stories? Do you have anything happy to talk about right now?
Nope.
Thanks a lot, Justin.
Well, we did break a record recently. Sunday was the hottest day ever recorded globally at 17.09 Celsius or 62.76 degrees Fahrenheit. Now, global temperature doesn't look so hot in terms of temperatures we might consider to be hot, but it's a global average and includes data from parts of the planet that are currently in winter. There were extreme heat warnings across many northern hemisphere countries. And so Sunday, record hottest day ever recorded. That is until Monday happened. Monday is now the hottest day ever recorded globally. 17.15 degrees Celsius or 62.87 degrees Fahrenheit. Climate scientists say the last time the world was likely this warm was about 125,000 years ago. Temperature rise in recent decades is in line with what climate scientists projected would happen if humans kept burning fossil fuels at an increasing rate. The previous record before this week was a year ago, but before that, the previous record hottest day was all the way back in 2016. Average temperatures were at 16.8 degrees Celsius or 62.24 degrees Fahrenheit. Without human-caused climate change, extreme temperature records would not be broken as frequently as is happening in recent years. But if the trend continues, it will be commonplace. It will continue to break heat records.
I don't like this. I don't know what I'm supposed to say to this. I mean, we've got we're breaking heat records. And this, like you mentioned, this is a temperature anomaly that's not really anomalous. This is something that is in line with changes over the last decade and 20 years more since we really started, especially with satellite data collection in the 80s. But the concern is that this is including the winter temperatures of the southern hemisphere. This is
It's a global temp.
it's global. Yeah. What are we supposed to do with this, Justin?
Well, at this point, all I've got I think we can say is we told you so. I mean,
Yeah.
what is there like? The government world thing, the people who are in charge of the planet aren't doing anything about it. They just aren't.
Mm-hmm.
And all of the scientists have given stark warnings. Like, really, like, gone out of their way to explain how big a deal this is. And it's being ignored. I don't think it's not being understood, even. I think it's being ignored.
Yeah. It's not convenient. I mean, there is something to be said for Al Gore's old movie, An Inconvenient Truth, right? His presentation, his movie that came from that. It is not convenient. And that language that was used, I think, is appropriate. But it's something that we look at this and we have to remember, though, and I'm going to say it over and over again when we see this kind of stuff. It's like, all right, this is not great, but there are reasons for optimism, right? We have scientists, people in technology who are working to create better solar cells, their solar energy, wind energy, water. Like, so much is going into sustainable energy production that I think this is great. And there was something else with nuclear fusion, and then something else with nuclear fission. There's a whole bunch of discoveries being made for energy production that perhaps, just perhaps, we will eke our way through this, right? Maybe we will step through it.
Yeah, and I think a future generation, not necessarily the current ones or the next one even, but after that, they may have a planet that has stopped warming. But it's gonna take, like, even if we had all of those things today, this trend will continue for approximately 50 years.
Yeah.
Even if we
because of our oceans, because we
which
have
give us oxygen and
But
do store temporarily
I feel like
as
we
a
have
carbon sink. I don't know how long that lasts, but it's like a 50-year cycle.
like, yeah, it's our atmosphere and then the
pushing it back
oceans, it's
out.
50 to 100 years. You have to think of like the ocean as kind of like a carbon dioxide bagpipe where it's just been like filling up and filling up and filling up. And you know that the bagpipes are going to start playing, and then they just keep playing until finally that carbon dioxide will come out. But at the same time, there's still carbon dioxide coming in, right? The air is coming into it still. So yeah, the oceans are a bagpipe. I don't know if you think that's good. I don't know.
I don't know. Depends on the opinion of bagpipes, I guess. No, but it's going to be like there's all like everything weather news. If you want to really have a fun career, go become a weather reporter, climatologist. That's going to be so much fun. It's like, yeah, so now we have a tornado that's going to run into a hurricane. At the same time, extreme weather is so common that these things happen at the same time now.
Yeah. And maybe
Texas
it'll run
is
into
gonna
a
be
little
hurricane
volcanic
tornado
eruption as well, and that'll be fine.
Throw that in there.
Maybe just that too. Oh, my goodness. Well, all right. Sunday, Monday, they were hot. It's probably going to be hot again. It's not the end yet. We're going to dive into a fantastic, we've gotten already into a great hurricane season. But maybe someone can just, grab on and, pull us out of here with a tractor beam. We can forget all about it. Beam me up.
So
tractor
at
beam
first
is
I thought you
not
were
the
talking about
same
like,
as a transporter beam. So actually, the people who wrote the press release, they got it all wrong. But anyway, nobody knows their sci-fi.
wait,
What?
are they saying tractor beam as though it's a teleportation thing? Is that what's going on?
Yeah,
Is that
yeah.
what?
I'm gonna be annoyed by the science writers from this organization, TMOS, from this institute. Um, it's great. TMS, it's great research in Australia, but this headline that it might have been shared and this framing that might have been shared elsewhere. Beam me out, Scotty. A new tractor beam technology aims to minimize biopsy trauma.
Ugh,
Tractor
ouch.
beams are not the same as transporters, right?
Yeah. Yeah.
They got it totally confused. So anyway, moving on from the pop culture references, tractor beams it's the idea that we could use some kind of gravitational or other energetic force to be able to grab onto objects of mass and pull them, be able to move them in ways that we want. This doesn't involve quantum stuff. It doesn't involve entanglement. It doesn't, as far as I know.
Unless that's
It
what gravity is.
maybe, right? Yeah, it could be that as well.
Still don't know what gravity is, why that tractor beam
No,
works.
we're not going to be knowing that anytime soon. Anyway, this tractor beam, no, it is not going to be moving giant starships at any point in the future. However, it could be used to move cells in people's bodies in a way that is less invasive and actually better for the cells. So there's less damage and trauma to the cells themselves before they are tested. So perhaps this would lead to more effective biopsies overall. How does this work? This, I think, is one of the most interesting little advancements. People have been talking for a while about the idea of a tractor beam. This idea that has been advanced by a group publishing in ACS Photonics this last week has put together the idea of a triphasic solenoid beam where a laser or other light source could be shot through what's called a spatial light modulator. The spatial light modulator might be, wow, people are being very loud in my house right now. Spatial light modulator would be a silicon wafer that's been like cut in a certain way to refract or move light through it. And the way that what they call metasurface would be structured is that if light is being shot at it and through it, the light that's in a straight path at that metasurface then gets turned into like a drill bit. But it's three light beams that spiral together. And so if you think of the way that a drill bit or Archimedes screw works to move objects like in a drill bit or a screw sense, it moves water up the screw or sawdust up the drill bit so that matter moves opposite the force of that drill, that spirally drill that's moving forward. And in this situation, they know that these spirals of light can engage and exert a force on matter that pulls it, that attracts it. And so the idea could be that this spiral of light would be available to grab onto cells in the body during a biopsy and pull cells from one place in the body to another, but with um, very little trauma on those cells. It wouldn't be like a needle going in and sucking the cells out. It would be a lot gentler. Well, yeah.
But it's light. How does it move things? This is the thing I just can't get my head around. Like, is it creating a heat thing? Is it creating a
It's not
vibration thing?
heat. No, and this I think is this is part of the fun aspect of this is that the triple helix solenoid beam. It has angular momentum, and the orbital angular momentum of the beams themselves, they have a diffraction gradient, and they actually have, because of the orbital momentum, they are, it is a force
So it's
multiplier in
like
the
Star
opposite
Wars?
direction. Kind of, but little
Force?
tiny. It's the force. But yes, light
Okay.
energy, because of the energy that it is propagating in a certain direction, because it has orbital angular momentum, that orbital angular momentum and the energy in the light beams is able to actually e- enact an attractive force that, in effect, because of the spiral nature, the polarized nature of the light, pulls objects, little tiny cells, or at this
So
point,
it's
little
like
teeny
lots of
things.
little tiny gyroscopes buzzing
Kind
around.
of.
Okay. Interesting.
Yeah.
Wow. Very cool.
Yeah. So anyway, I think it's a um, pretty fun new development. This study is adding to previous evidence about these kinds of orbital angular momentum effects and the idea of these, like, Archimedes screw, right? In using light to create optical tractor beams, rays of light that actually pull little teeny tiny particles towards them. So far, it's little teeny tiny particles. And in the study, they were able to characterize a beam at a distance of 21 centimeters. This enabled them to start to have an impact on things that could be up to cellular size. And the next stage is going to actually demonstrate that they can do it. Right now, they've created the meta surface that creates the beams that can then lead to this development. So they're getting there. They're not there yet. But yeah, little baby tractor beams coming to a hospital near you someday soon, maybe.
Hmm.
Hmm. What else do you want to talk about?
Let's see. Oh, cut marks on fossils could be evidence of humans exploiting large mammals in Argentina more than 20,000 years ago.
What?
According to a study published in the open access journal PLOS One by some folks at the National University of La Plata, Argentina. So this is a big deal. This is the accepted evidence of humans in South America currently is at about 16,000 years ago. So the radiocarbon dating indicates these fossils are maybe even 21,000 years old, much older than any of the other archaeological evidence of South America. And what this is it's cut marks. It looks like the animal has been rendered intentionally.
And these, so okay, 21,000 years, South America,
Mm-hmm.
cut marks. Is this new evidence in addition to other evidence of more than 20,000 year old ancestors in South America? Like, is this adding to that, or is this adding on to what we already had?
So it's 6,000, 5,000, I guess, years older than anything that they have as accepted data. Now,
Hmm.
there have
Okay.
been sites and areas, and genetically, when we roll things back, people it must be much older. This area could be older. That could be older. Sure. There's all that speculation, right?
Sure.
But this is a megafauna that we know went extinct. These are stone tool cut marks on the animal. And again, depending on where you are in the world, the climate is better or worse at preserving traces of humanity in an archaeological record.
Yeah.
South America is particularly terrible because it's it's very moist and wet in a lot of areas, and so there's a lot less likelihood that you're going to have a dry area that is covered and preserved in some way. But this is at the lowest mark of a very deep dig site, where they've been sort of going back in time, looking at different things that they could find in this depression as they excavate it out. And there's still further to go. There's further back they can excavate this particular site. And so it's going to be kind of exciting to see if there is more that they can find. But yeah, statistical analysis finds the cut marks on parts of the pelvis, tail, and body armor are consistent with known marks made by stone tools, and the placement of these marks is consistent with a butchering sequence targeting areas of dense flesh. That might be, we may have pushed back the hard evidence-ish of human activity in South America by 5,000 years. Now, we've got sites in North America that we know now are over 20,000 years. I think even over this 21,000 years old. There are speculative sites as far south as Mexico that could be 30,000. We have sites that are around 20,000 up in the Yukon, up in Alaska to the very north, over 20,000 down to the south of North America in New Mexico. And we have lots of sites in South America that are 16,000 years. You know, we've been not pushing back these dates every time we get a new finding, but this is a pretty significant one, because now it would be one of the oldest evidences of human activity in the Americas in South America. And it's
and real activity, not just like genetic evidence that this had happened through mutate. Like, we're looking at modern people and going, hey, mutations suggest this happened 24,000 years ago, or there's this other evidence. Like, this is pretty solid evidence.
And actually, the genetic evidence is challenged by all of these things, because the predecessor of the Native Americans in northern Siberia is not supposed to have been is younger. Is younger than the evidence that's being found in Americas. So then,
no, I mean, we've got evidence now of humans going back 50,000 years, or of there's evidence of early art in Southern European and Eastern European regions, going back Indonesia, going back at least 24, if not 40 to 50,000 years ago. From
two things. For the specific group I'm talking about, that I can't remember exactly what they're called, but I think it's the Northern Siberian people or something like this, is a genetic lineage that they think that the Native Americans were from.
Which some very well could be, but that's Northern Native Americans and different groups.
And Southern.
Okay.
It's the same over time, but it's but the problem is the genetic origin tracing back of that Northern Siberian group is less than 20,000 years. Meaning that particular group that they have hypothesized as the one that genetically gives rise to all Native Americans in the Americas, the evidence for that one doesn't go back like as far now as we are finding evidence of peoples in North America, which isn't to say that the more evidence wouldn't be found, but it was used as, we find this is older, and then we have the less old version of it over here, so therefore this must have led to that. But now the arrow looks like it points the other way. So I'm not saying that the people of the Americas necessarily are the ones who became these Northern Siberian people, but it's also possible, because they could have been there much, much longer than we have guessed. Also, the thing you said about the art.
Yes.
I know don't let anybody,
and
I know you're not making this claim, but don't let anybody convince you at all about when art was invented. Art has, I'm
yesterday?
sure. been as
Kidding.
much older than anything that we're going to find in the record. Yes, we're going to only find the stuff that was either on a rock cave interior wall somewhere that was well preserved from the elements, or something that was scratched into a stone. We might see those. Okay. But those won't be the oldest, because people will have been doing art and crafting things for artsy reasons way back into the distant ancienter past than we can see. Because even
No, everything has
our
always only been survival, Justin. Only survival and ceremony for important things. That's it.
even our most acclaimed artwork in the modern day is usually only expected to last like 100 or 200 years or something. Like, it's cultivated in climate controlled museum environments, and we have people who are trained in repairing that art to make it seem like it hasn't completely crumbled away into nothingness. But
we're not hiding our art on walls in
doesn't last
caves.
that long. Yeah.
Which is what we need to do.
Yeah. Well, but it's there was, I'm sure, plenty of art that was being made, but on what kind of surface, with what kind of things? It wasn't built to last for generations, maybe.
No.
Oh, what's this?
No, it's some of the cut marks in megafauna bones that are from armadillo-ish like animals off of the osteoderms from the carapace of these animals. I'm showing pictures. Some of these bones and these cut marks that appear intentional. So many fun intentional things. Do you know what's
fun fact, this was shortly before they went extinct.
Oh, great. Not just the mammoths. We also helped to get rid of these
what do we say? That's what humans do.
Neoscleroliptus glyptodontidae. I'm not a dinosaurologist.
Extinct Argentinian armadillo.
Yep. Very large one. Speaking of completely not on purpose, or maybe, I don't know, butterflies can now, and moths can now be added to the list of animals that are static electricity attractive. Butterflies and moths, with their flying through the air and their wings, they create a static charge. And these researchers just publishing this last week in the Journal of the Royal Society Interface have shown that it's not just one butterfly species or moth species. It's not just all of them exactly the same. In fact, when looking and comparing butterflies and moths across the Lepidoptera family, we start to see a trend that the electric fields that are generated are species specific, environment specific, and not necessarily something that is predictable based on simply body size. That there are a lot of factors that go into it and suggest that it is a very adaptive feature and that it works to attract pollen to these species that are known to be pollinators. And so moths and butterflies, depending on if they fly, butterflies during the day, moths at night, if they're in the tropics or in the temperate regions, that these different species have correlations biogeographically, ecologically, and charge accumulation is actually important to pollination, predation, and parasitism. And they are, for the first time, as they say, introducing the idea that electrostatic charging might be a trait upon which evolution can act. We've talked about this a little bit in previous shows, that spiders are using electrostatic charge to move through the air, that there are different species like bumblebees that are using electrostatic charges to find flowers, that there might be some amount of electrostatic information involved in signaling through the air when a flower has pollen it wants to release versus other times of the day, night, year. And so now this research really suggests that indeed butterflies and moths, they're shocking. Dun, dun, dun. Or not shocking.
Hype sound.
Hype sound. Yeah. But, I think it is very interesting that it's not specifically predictable, that the electrostatic charge that's produced is not specifically predictable by the size of the butterfly, that it's something that is, it's very specific to where they live, when they're active, so many other factors. And this is something that seems to be across different species. Yeah. Butterflies, they like flowers. So do moths. The pollen is attracted to them across gaps of space in the air because butterflies are like balloons that we play with. Right? Except they're not a balloon and rubbing it against your hair or rubbing your stocking feet against a carpet. They are just flapping their wings against the air and suddenly charging up. Yeah. I wouldn't have thought this of butterflies previously, but yeah. Hey, butterfly cuties. You're pretty good. A little shocking.
Very cool.
This is This Week in Science, everybody. Thank you so much for joining us for this episode of our program. We do hope that you are enjoying the science so far. I cannot speak tonight. That you're enjoying the science so far. And if you are, please share This Week in Science with your friends, your coworkers, other science enjoyers along with you. And you can head over to TWIS.org, where we have links to our Zazzle store, where you can find merchandise. A lot of it all of it TWIS related. Some of it has been created by our wonderful Blair, who is not with us tonight and who apparently has COVID. I hope she gets better very, very soon. And oh no. Also links to our Patreon account. So you can go to twis.org, click on those Zazzle links, head over to Zazzle and find cool TWIS products to help support the show, and that you can wear around and feel super cool because you have a TWIS towel or doormat or lumbar pillow with cool animals that Blair made, or just know that you are supporting TWIS in an ongoing fashion by being a part of our Patreon community. You do know that $10 and more per month, and we will thank you by name at the end of the show. I will really do my best to pronounce your name tonight. I really, really, really will. But you all know, I do hope that we really cannot do this without you. We wouldn't want to do it without you. We're so glad that you're here. Thank you for supporting TWIS. All right, everyone, gonna come on back, but we do not have a Blair's Animal Corner. No, we do not. I brought animal stories, but I was gonna save them for a little bit later. I was gonna, right now, head over to a Justin story, but Justin isn't back yet. He's taking a small break, wandered off to get a cup of coffee because it's early in the morning. Oh, private chat. Burby. Burr. Okay, well, anyway, now I know. See, if I look at the chat, sometimes I will learn things. Okay, everybody. I'm going to tell you a little story about a relative of ours called the chimpanzee. The chimpanzee, who not as closely related to us as the bonobos, but still very closely related and incredibly cool animals. Chimpanzees have very complex social structures and, in addition, communication structures. We know they make loud noises, they at each other, and they make hand gestures, and they run at each other, and facial gestures, and all sorts of stuff that goes on in the land of the chimpanzees. study out this last week in Current Biology. This is an open access journal, so if you're interested in taking a look at it, you can. We will have a link to it in our show notes. But this particular study I find incredibly interesting because they have taken a look at not just the sounds that chimpanzees make as they are communicating with each other, but also gestures that they make to each other back and forth. And no, they're not all rude gestures. Chimpanzees they're cultured in a sense. They have culture. They have different groups, and those different groups have different cultural standards, which is pretty exciting if you think about it. And this paper looks at these hand gestures, these communication techniques between the chimpanzees, and has determined that chimpanzees, they're just like us. Who knew? The reason they say they're just like us is that the latency between the gestures that they make and the way that they respond to each other is just like humans. We respond and we talk to each other in conversations. We're like fast talkers, slow talkers. Different cultures have different kinds of responses. Apparently, according to the study, people in Denmark are very slow responders, that they're like slow talkers in the world generally. And in this study, we have learned.
Wait, Denmark is slow talkers?
Yes, that's what the researchers say. They're slow talkers.
They need to go to Copenhagen because like literally this is the problem I'm having with learning the language. Is it
too fast?
I guess they're a bit monotone.
Mm,
They're not as sing-songy as other languages, but they do this.
maybe.
They have this trick of combining words together, slamming them together, and so you can have these statements that sound like one word. The sentence will sound like one word because it'll all kind of be jammed up together. So it's I'd push back on that slow talker thing. I don't think they so much talk slow as they because they shorten all of their words into one sound.
Okay, so the people talking in their response don't particularly talk slow, but in their responses, they don't respond as quickly necessarily as other people, according to the researchers. And so
they do take
there's
a
an
moment
average there's an average response rate in humans of about 200 milliseconds. And people have a tendency to hear each other and sometimes interrupt and go, oh, I know what you're talking about, and then blow and start talking. And we can get up to like 150 milliseconds of, or 120 milliseconds of like boop, 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 response time. And we start with our hands and we like talk and we talk over each other. And that's our conversations are very much like that. There is a period of time of listening, recognizing, and responding. And these are structured responses that have norms and averages. And there are some individuals that are faster in responding than others. And there are some cultures where it's more common to respond quickly than others.
Yeah, and California people will always finish your sentences if you're talking too slow. But in Denmark, no, that's a good point. They do. There is like a wait until the other person has stopped completely before you say something. I get in trouble for all the time because I'm from California.
Here.
And I will finish
California,
your sentence.
You're like, what? I finished your sentence.
But I'm letting you know. I'm on the same page. I'm actively listening. They are listening, but they're not actively participating in response until you are completely done.
Yes. And so in the case of these chimpanzees, what they discovered with the analysis of their response rate is that the chimpanzees respond as if they're having a conversation. Very similar response rates to humans, very similar average responses, and also variation between individuals. Not just that, cultural differences. So when they looked at different populations of chimpanzees, some chimpanzees had a more chill way of talking to each other with their hand gestures, and other chimpanzees were much quicker and on it and interrupting each other faster. And so there are Californian chimpanzees and there are Danish chimpanzees. And I don't know what this says necessarily about the different cultures and the thought processes that are involved, but what the researchers are interested in are the indications of how this what this suggests about the evolution of communication as a whole. If this hand gesture and response time communication is indeed indicative of this listening, understanding, or at least recognizing and having because we have a theory of mind, being able to kind of have a synchronization of what you think the other individual is getting at and being able to respond to them within about 200 milliseconds. What does this mean for when this process got started? If this is chimpanzees, is this something that's going to be common with other social species like corvids? Will crows have response times on a similar scale? Will it be faster? Will it be that we'll find similar relative timings dependent on, different brain sizes, different social structures? Is it because these are primate relatives that it's so similar? There are a bunch of aspects here that are, questions that are very open and that we really do not have the answers to. But there's definitely communication taking place between these different animals.
Hands are good at communicating. Anything that's got them should probably try it out, right?
Sorry.
Oh, we got Clippy. We got at least on my end, there's an internet Clippy buffering frozen thingy going on. Oh, and I think it just might be my end. Because my internet doesn't look like it's happy. Apparently, I'm still coming through. It's Kiki that's just frozen. It's not that it looks frozen on my end because my internet went wonky. All right. Well, in that case, if you guys are hearing me, I will continue doing show stuff. This is this is not a good story. This is a new Cornell University study that is providing evidence that avian influenza from birds to dairy cattle across several U.S. states has led to mammal-to-mammal transmission between cows, from cows to cats, and from either cows or cats to a raccoon. This is one of the first times that we are seeing evidence of efficient and sustained mammalian-to-mammalian transmission of highly pathogenic avian influenza H5N1, says Diego Diel, the Associate Professor of Biology and Director of the Virology Laboratory at the Animal Health Diagnostic Center at the College of Veterinary Medicine. In the study, spillover of highly pathogenic avian influenza H5N1 virus to dairy cattle. I can't tell you what's in the study. It's under embargo until 11 a.m. Eastern Time tomorrow. I guess it's your tomorrow. So I haven't read it. But basically, this press release teaser of the story is confirming mammal-to-mammal transmission has been going on. Whole genome sequencing of the virus did not reveal any mutations in the virus that would lead to enhanced transmissibility to humans. We have a different immune system than cows and cats. And so far, it's fine. It's not going to go directly to humans. Although the data clearly shows mammal-to-mammal transmission, which is concerning, as then the virus has the opportunity to become a reservoir there, and in so doing becomes more likely to adapt to other mammals. So far, there are 11 human cases that have been reported in the U.S., and they are often linked to the dairy industry. So it kind of makes you wonder how, in those cases that are linked to the dairy industry, also not include cow to human transmission, right? That sounds like that's already happening. Whether you've seen those mutations that make that likely or not, there are 11 human cases that have been reported, and many of these are linked to cattle farms, and 4 are linked to cattle farms. 7 have been linked to poultry farms. So, how sure are we that human to human transmission, there's cow to human transmission, perhaps. There's poultry to human transmission, perhaps, but maybe not human to human. Because so far it looks like the virus is not replicating or able to replicate within humans. So that's our safety point right there. If you get it directly from a cow or a chicken, you're not likely to infect anybody else with the virus. Oh, now I have to take it all back because I thought it did not have to. It says, while the virus does have the ability to infect and replicate in people, the efficiency of those infections is just very low. So the concern is that potential mutations could arise to lead adaptation to mammals, spill over into humans, potentially efficient transmission humans. So I have to take back everything I said about it not replicating in humans because it can. It's just not good at it yet. Anyway, the study has been embargoed. I haven't been able to read it. It will be available later today. Maybe we'll talk about it more on next week's show. And
the cows and the flus. I'm back.
Yeah, so it's an embargoed study I'm trying to talk about. That I haven't read the embargo.
You can't talk about it if it's embargoed.
I can because I haven't read the study. I can talk about what they're talking about the study. Yeah. But I haven't read the study, so nothing I'm saying is from the study.
From the study.
Directly. But this coverage of the embargo, to me, is fair game. They're going to put out a press release about their embargoed study. Why then? That's the thing we will talk about because it was released to the press. But this actual study itself is still under embargo. But it was, I messed up because I thought it was, the whole point was that it can do mammal to mammal, but it's not concerning humans because it's not replicating and transmissible from human to human. And it turns out it is actually able to infect, not just infect, but replicate in people.
Yeah.
But the efficiency of the infection is low, and that's why they're not concerned about human to human transmission at this point because it's not likely. But it's confirmed cow to cow, cow to cat, cow or cat to raccoon transmissions have taken place.
Yay! Go viral evolution.
Nothing to worry about, I'm sure, are the most famous last words every time somebody tries to underplay.
It's fine. It's totally fine. And that's when I play with my hair some more.
And my last story. You wanted a good story. I finally have one.
Do you have one? Please. Okay.
The ability to regenerate body parts is something that happens in nature. You can cut off the leg of an axolotl, that sort of adolescent salamander, I think is what they are. The arms of starfish can be removed and grow back. The tail of the salamander. All of these things are things that a body part that can be lost and will all regrow in a month or two. Researchers have found that this superpower has a shared ancient genetic root, newly sequenced genome of the brittle star. Particularly impressive regenerator reveals it uses many of the same genes to regrow its limbs, as do the far distantly related animals. What does this suggest? It suggests that the mechanism is not co-evolutionarily derived. It is did not evolve in different species independently, but that it has perhaps been preserved for hundreds of millions of years. Meaning, hundreds of millions of years ago, that's a long time ago, regeneration may have been much more common in early life than we might have suspected. And some just managed to hang on to it. What really stuck out to me is the bulk of these organisms that can regenerate have this shared program of cell growth, says Shruti Naik, a regenerative biologist of Icahn School of Medicine at Mount Sinai, not involved in the study. This paper allows us to have a clear cross-examination of this regenerative capacity across various evolutionary scales. They really give us a bird's eye view. Brittle stars is a kind of echinoderm alongside starfish, sea urchins, sea cucumbers. They sport 5 spindly arms protruding from a central disc. Many can regenerate their limbs if they're cut, but brittle stars do this at an immense speed. Says Elise Perry, a geneticist at the University College London and a lead author on the study. One species will fully regrow an arm within just 4 weeks. This makes it an important model to study on the genetic, looking at the genetic basis and underpinnings of regeneration. Now, some of these organisms obviously are a little less complicated than a human, but these are things that, sort of ideally we could, especially with how gene therapy and everything else is coming along, we could perhaps target specific tissues, maybe something like an eye, maybe something smaller. Maybe we do this for an area of brain damage and create neural or brain matter regeneration. Team looked at which genes were active during different stages of regeneration, cutting the arms off more than 3,500 brittle stars, measuring RNA levels as the arms regrew in the following days and weeks. So the RNA levels are going to be proteins expressed by the genes. So you can see what's being activated, what genes are creating the proteins to go and address the lost limb. They found that in the initial stages of regeneration, when the wound was beginning to heal, the brittle stars expressed genes that had evolved relatively recently. But during the proliferative phase of regeneration, where cells rapidly divide to replace lost tissues, it expressed ancient genes it had acquired hundreds of millions of years ago. This suggested the brittle star inherited the ability to regenerate limbs from an ancient ancestor, that other animals may have acquired their regenerative powers from the same ancient lineage. To test the theory, the team compared the genes that the brittle star expressed during regeneration with similar data from 2 distant related creatures known from their ability to regrow body parts, axolotls and a small marine crustacean. Researchers found all 3 animals shared. Which was the third one? Oh yeah. The first one. The researchers found all 3 animals shared genes that are active during regeneration, particularly during that later proliferation phase when all the rapid growing and regenerating is really in full swing. So yeah, now we need to figure out how we can use this for humans so we can regenerate more humans.
I think the most interesting part of it is adding to the brittle stars. Okay, long ago ancestor kind of relative, but then you get the axolotl, and that's a little bit more complex and a little bit closer to our body structure. And so you start seeing these common instructions, and I think that's where it starts getting interesting.
Yeah, it's also, as Noam saying in the chat room is saying, new gene therapy, Wolverine and Deadpool regeneration for everyone. So it is.
Right? Wouldn't that be great?
This is one of those things that's like,
yeah,
It's sort of like if we discovered, oh, yeah, actually a lot of animals have X-ray vision. Or a lot of
Do
animals can
they?
fly
I'd like
without
that.
wings. Like they just have a
Yeah.
superpower. Oh, wow. Superpower's real. It's so cool.
But in this
Those are-
case, it is growing back appendages. I mean, it I think it's good. The talking about Deadpool, Wolverine, okay, yeah, he heals fairly well, but it was that little baby arm, I think it was in the first Deadpool movie, that just really got me thinking, how fast could something be grown back, right? Do you grow it back? Can you get it to grow back at double speed? How does it grow back? And does it have the right instructions to make it all work? And apparently it does, according to this the chromosomal instructions, but it's just a lot of the instructions that keep things from growing back, I think, are the interesting, right? It's like we have instructions in the human body to stop things from growing back.
Mm.
We could grow more things back, except
Well, we also have this thing where we can bleed to death. Right?
oh yeah, there's that. And also
we have this we have scar tissue that gets created to protect where there has been a wound or a cut. It's sort of how we patch things back up. And apparently that interferes with the process of regeneration also. The creatures who are growing back tails or limbs are not forming scar tissue over those areas. If they do, then they cannot grow back.
So we need to have regeneration that allows for scar tissue when scar tissue needs to form or just needs to eat the scar, eat the scar tissue to reform stuff, or just never allow it to form in the first
Now I want to
place.
go back further. I want to say, like, okay, so maybe the improbability of life on Earth was made a lot less probable because 400 million years ago or 500 million years ago, all life on Earth could have had this ability. Maybe this is something that's not just was gained in a few species late, but maybe this is something that's was a common thing very early on. And if so, that might explain how life managed to survive all of the hostile environments it first encountered.
We don't need it anymore. We're so soft.
regenerating.
Our ancestors would be like, "Oh, kids these days, you're so soft."
Just grow another head, like the little Hydra. That little Hydra.
You could cut off everything, and it would regrow
Everything
a head.
would grow back new ones. Yeah.
Oh,
You
I
can
lost
cut
a
off the
head.
tail, and the
I'm
tail
gonna
will grow a
back.
new head. You cut the tail, cut an arm off the Hydra. It grows a whole new Hydra. It doesn't care what part you cut off. It's like, just grow it back. You know what to do.
Studies like this, though, they're very exciting for being able to put us in the, I don't know, the right ballpark, a better ballpark for being able to figure out how to solve some of these regeneration issues that we struggle with today. Will we be able to fix some of our, will we be able to transplant things better if we learn about the genes that are involved? Will we be able to grow back organs, limbs better?
I guess we can do it a little bit. We can do that to the liver, right? Doesn't the liver grow back a little bit?
A little, it does. Until you just damage it so much, it says, no, I'm not doing that anymore. I don't like you.
Yeah, or specific organ regeneration, even if it's just, I really think the eyes. I think the eyes would be a good target because there's something also. What is it? Is it fish or frogs or something that can currently do this? Like, it seems like we need to get on that.
I think so. If frogs can do it, then we should be able to do it. Totally. Moving on from frogs, let's jump to cuttlefish. Let's take that lily pad right in cuttlefish land. Yeah, cuttlefish. You don't cuddle with them. Yeah, cuttlefish, they're not romantic, really. They don't cuddle, do they? I don't know. Anyway, I'm not going to follow that line of thought. But over the years, we have talked about their amazing memory. And since the mid 2000s, we've been talking about these studies in the cuttlefish that have shown that they have really good memory. They actually have episodic memory where they can remember where they found food, when they found it, what kind of food was there. Like they're on a par with a lot of other very complex organisms in terms of remembering things. In addition, their memory gets better throughout their life, unlike humans, where our memory gets great and then it just gets worse. They don't have a hippocampus. We have a hippocampus that's supposed to help us with all of this memory stuff. How do they do it? What's going on there? How is their memory so great? Why is it so great? These are questions that researchers are trying to figure out. And so, in this latest study that's published in iScience, researchers about a week ago published their work in cuttlefish, basically messing with their memory. So, in this study, the researchers said, hey, all right, you got really good memory. What if you get confused too? Would you be a flawless witness on a witness stand if you were a cuttlefish? Or do you too get fooled and have false memories? The bottom line is, yeah, cuttlefish are susceptible to false memories. That's pretty much the bottom line of this work. They did a study to mislead cuttlefish. So they gave them their preferred prey and they gave them a less preferred prey, and they had a few situations where there were different cues, like visual cues for the cuttlefish to be like, oh, okay, there's this thing happening, there's an odor for my prey, and so the prey wasn't actually there, it was just the odor of the prey. And so they had visual cues, odor cues. They had a regular event like, oh, it's checker box time, and that's my preferred prey. Or, oh, it's checker box and black box time. I don't like the black box, and meh, where's my preferred prey? It's in there somewhere. Because of the conflicting visual cues, checker box and black box, and the preferred prey being involved in both of the situations, the cuttlefish were very likely to get confused and, with visually misleading events, to have more of a random chance performance on the tests. Because they were like, the false misleading event was like, it could be either one of these things. And so they were like, yeah, either one. They just couldn't figure it out. So when given another visual cue on top of their checker box cue, they just got confused. I don't know. This could also mean that too many visual signals is confusing to the cuttlefish and they just don't care anymore. And they're like, whatever, man. But really, what we're seeing here are the cuttlefish getting confused. They're easily confused by the perpetrator. Was he wearing a white sweatshirt or a black sweatshirt or a checkerbox sweatshirt? And was the perpetrator my favorite prey or my less favorite prey? I don't know. Depending on the prey species, preferred or less favorite, the cuttlefish were more likely to get the visual cues confused and to be misled by visual cues, not the olfactory cues so much. Olfactory cues enabled them to figure out what was going on. But when visual cues were involved, they were more likely to just kind of have random performance. So anyway, cuttlefish, they get confused too, just like us. Do you want to know more about cuttlefish?
Yeah, always.
Yes, please. I like cuttlefish. Cuttlefish
Cuttlefish
really.
already have a superpower, don't they? They're like they have that ability to mimic their surroundings with incredible, at least to the human eye, incredibly
Yeah.
blend in with backgrounds, and then really synthetic backgrounds as well, not just organic ones that they happen to be in.
Yeah, and so this is one of the interesting aspects of this study is that they're not just olfactorily, or the scent of the prey isn't the thing that's leading them on. They're very visual species. They have coloration for mating. They have all sorts of signaling that's related to visual cues. And so the locations of things, the contextual cues that are visual should be very defining for where their favorite prey is or their less favorite prey. But in this situation, they got confused. Too many visual cues were too much, even though they are an incredibly visual species, which in itself is kind of interesting. So what does this mean? We're just like them. But more than that, what this says is that cuttlefish are what the researchers say is that these visual cues get in the way, impair memory retrieval. Memory retrieval is kind of like ours, with this reconstructive process of what they've seen before or experienced before. A new cue gets in there and it's like, oh, was it white? Was it black? Was it checkerboard? Whatever. And if there's no misleading, the cuttlefish, they can remember it. So if you ever want to confuse a cuttlefish, change the color of your shirt. But it's really interesting that they are so visual, and that yet the visual information is part of what confuses them. But maybe this is an aspect of the limitations of their memories. And because they form false visual memories, but not false olfactory memories, which is interesting. My last story for the night is still suits. If you've ever read Dune, watched Dune, the old Dune movie, the new Dune movies, ever had a conversation with sci-fi fans about what the heck are we going to do in space on other planets when we're walking around and we need water and there's no water? What do we have? We have water in our bodies, and we have waste systems in our bodies, and we need to get rid of waste in our bodies. We produce copious amounts of waste products in the form of urine and others. And currently on the International Space Station, we have special toilets that are hooked up to systems which recycle water. When astronauts, cosmonauts, taikonauts, whatever, are on the space station and they have to go to the bathroom, they do so. They relieve themselves into these space receptacles, and the space receptacles then use osmosis and other techniques to remove waste products, salts, and other stuff that's in the wet versus dry products. And the wet stuff turns into water, and that water is totally clean, becomes drinking water again, and also helps to water plants and other stuff on the International Space Station. Currently, the space suits that our astronauts wear are not made for long environmental missions. Currently, astronauts wear diapers. There is no recycling of any waste products. Astronauts have to limit the amount of liquids and foods that they take in prior to any of their missions outside in the suits. If they take a long time, then they have to go, and then it just is held in a diaper, and then that diaper is just disposed of. That's
It's so tough to be an astronaut. You're all the way up there. You spent like 30 minutes gowning into your spacesuit. You get out there, you're on the tether, and you're trying to do the repair thing, and then you're like, "Oh man, I gotta go back in. I forgot to pee." Oh
Nope.
no, you gotta go on with the
You
mission.
don't-
You gotta stay out there. You gotta.
You don't get to pee. That's it.
Hopefully, you remember to wear your diaper.
That's pretty much it. Because if they were not to wear the diaper, then it would ruin components for communication and environmental control within the suits, and it would not be okay. And in fact, with the diapers currently, we know that if astronauts use them for too long a period of time, it can lead to urinary tract infections, and also if you don't want to go, you hold it, and then you have gastrointestinal distress, and that's no fun because you're trying to do work and you're like, my tummy hurts. Anyway, researchers just published in Frontiers in Space Technologies their new enhanced astronaut hygiene and mission efficiency approach. It's a still suit, in-suit waste management and water recovery in spacewalks. They say in their what is currently known as the EMU, extravehicular mobility unit, it's like I said, disposable diaper, what is called the maximum absorbency garment, or MAG. And this is used during those up to 8-hour-long extravehicular activities, EVAs. Okay. They have about a liter of water in their suits. They might sweat while they're working in their spacewalks doing stuff, but really they up to a liter, and then they have to go to the bathroom, and hopefully that MAG is able to hold everything. And this suit now, they are aiming to achieve an 85% urine collection rate using a modified MAG. You know what this modified MAG is going to be? Pair of
Bigger
pants.
Pair of pants.
Pair of pants.
A whole pair of pants.
A whole pair of pants. Well, it's a pair of pants with a special collection cup. And the collection cup will have a wicking fiber. So if you imagine your fancy athletic shoes or the fancy workout shirts that you have that are like sweat wicking technology, special fabric that wicks moisture away. Well, they're going to put that in a little 3D printed plasticky cup, one made for men and one made for women, not men and women or people of various genders do not have to wear the same clothes anymore. Whatever fits best, we can make it work. But yes, these pants will have a special cup that it has special fabric that wicks it away, and then has RFID-based electronic technology that as soon as moisture is detected, the electronics will begin to work to suck and wick the urine away into the pants. And then the system will use specialized forward osmosis membranes and reverse osmosis membranes that could then return the fluid from the urine to the drinking water within the suit. So time in a suit could be expanded and enhanced, and comfort maximized. You too can drink your own urine when you go to space.
That part actually isn't even the part that I find horrible.
It's great.
Water is going to be water once you've done the
once you've taken all the stuff out again, it's just water. It's great. Mm-hmm.
It's just like, I was picturing like a couple of astronauts sitting down on the moon talking. All of a sudden, one of them's pants cup pump turns on. It's like, oh, are you peeing right now?
How loud is it going to be?
I like being on Earth. Have I ever mentioned that? It's a good planet.
You have mentioned it before. I know. And in
wear the pee pants, the motorized pee pants,
but
diaphragm water pump pee pants.
But in the
Wow.
same way that other technologies have led to advancements for things like Velcro, Spam, frozen, freeze-dried ice cream, this too, may one day move ahead from a random jumble of wires and components connected to a laptop and actually become a pair of pee pants for your spacesuit.
Or, I could picture lots of like
Mhm.
truckers,
Long distance,
underpaid
right?
shift
Airline
workers, like
pilots,
lots
right?
of people
Underpaid
could
shift
probably
workers.
could
No.
probably be wearing these in no time.
Gamers.
Oh God, the gamers. Yeah. Yeah.
You never have to get up and well, maybe you have to get up and change I'm sure that the membranes need to be changed
You just need to
occasionally.
prevent the blood clots in your body from collecting by getting up and
Don't
going to the bathroom. It's
let
life-saving.
the blood clots sit. You gotta move around, move the blood clots a little bit. Doo, 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 doo.
Yeah. Okay.
Yeah.
People on Earth will use this for sure.
Absolutely. And, the idea right now is this kind of bulky, just proof of concept, just an idea. They've come up with the plan for how it would work. They've come up with designs for these specialized cup for male and female anatomy. They've come up with special pants with the special fabric, water wicking technology, moisture wicking, and all of it with multiple layers of fabric and then fine tubing, capillary action. Suddenly there are membranes and osmosis involved, and suddenly your water bag stays full, or at least ish. We can go everywhere.
Stay hydrated, people.
Yeah, stay hydrated. Stay hydrated and wear good pants, please. I don't know. Have we done it? Is that all the stories for tonight? Do you have more?
Yeah, I didn't bring any more. That was it.
That's it for the night, y'all. I miss Blair, but I'm glad Justin's here. And I'm glad all of you have been here as well. I hope Blair gets better, that her COVID passes very quickly, and that we see her next week. She was already planning on taking this week off for another work function, but fingers crossed she's back next week and healthy. But in the meantime, thank you all for joining us for another episode of This Week in Science. More science, more fun, more conversation, more questions. Always. We do hope that you enjoyed the show. Shout outs to a few of our favorites. Fada, thank you so much for helping with show notes and social media. Rachel, thank you for editing the show. Identity 4, thank you for recording the show. And Gordon Arlenor, thank you for keeping our chat rooms nice, happy places to be. All you chatters, thank you for being in the chat rooms on YouTube, Twitch, and Facebook, and on Discord. I see you. I really do. All the comments. And I do always have to thank our Patreon sponsors. So without further ado, time to read the Patreon sponsors. Oh, but I closed that window because my computer died. Oh, but here it is.
Oh, no.
Dun, dun, dun. Here it is. I found it. Thank you to Eden Mundell, Alan Viola, Aaron Anathema, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Trent Northcote, George Corris, Pierre Velazar, John Ratnaswamy, Chris Wozniak, Vegard, Chef Stad, Donathan Styles, a.k.a. Don Stylo, Ali Coffin, Reagan Shubu, Sarah Forfar, Don Mundus, P.I.G., Stephen Alberon, Dara Myshak, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hassenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Johnny Gridley, Jimmy Day, G. Burton Lattimore, Flying Out, Christopher Dreyer, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Phillips, Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, E.O. Adam Mishkon, Aaron Luthen, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, Tony Steele, Darn it. I read all the names, but there's the list. I forgot to put it on the page for you all. See, there's the list of the names. Thank you all, Patreon sponsors. If any of you would like to sponsor us, support us on Patreon, please head over to twis.org and click the Patreon link at next week's show.
We will be back. What time? Wednesday, 8 p.m. Pacific time, which is also 5 a.m. Thursday, Central European time, broadcasting live from our Twitch, YouTube, and Facebook channels.
Oh, yeah. And for more information on anything, oh, wait, no, I don't know how to read anymore. If you want to listen to us as a podcast, we do that. We podcast. We take this, we edit it. It comes into becoming podcast. Search for This Week in Science wherever you find podcasts. And if you enjoyed the show, please get your friends to subscribe as well.
For more information on anything you've heard here today, show notes, links to the stories are available on our website, www.twis.org.
You just stopped. You're not even saying it anymore.
Well, because there is no newsletter. I'm going to quit typing a newsletter that doesn't exist.
Are you sure?
Years.
Are you even signed up?
I might not be signed up to receive it. Maybe it is going up.
Right? Maybe that's all it is, Justin. Maybe you just need to sign up to receive one.
Okay. I just don't like giving out my email. I'm just weird like that.
All right. Okay, fine. We love your feedback. We really do. And if there's a topic or an interview that you want to request, please let us know. And you can let us know through social media. We're there sometimes, kind of ish. Yes. Or you can just send us an email. Put TWIS into the subject line so your email does not get spam filtered into the false memory of a cuttlefish.
It says to send an email, but it doesn't say what the email is.
Any email.
And just send an email, put TWIS in the subject. Doesn't matter who you send it to. It comes to us.
You will find us. We have a website, twis.org. There's information. Find us on the internet. I'm sure our email addresses are out there. I'm sure people can find us.
Why is our email address not part of the... Anyway.
Because there were so many once upon a time. I deleted things to make it more tight and a tighter ending.
We look forward to discussing science with you again next week. If you learned anything from the show, remember...
I'm going to say it. It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views. But I've done the calculations and I've got a plan. If you listen to the science...
What's up, Kiki? You're dancing. Isn't it the middle of the night there?
It's 9:43.
And you're just getting your dance on. Oh, my goodness.
It's summer vacation, which means
ooh,
my child and I have similar sleeping habits.
Uh-oh.
I know, right? I'm like,
no sleep till autumn.
Yeah. No, there's lots of sleep. It's just not at the regular hours. I go to bed late, get up late. It is so wonderful. I love being in my clock shift. It's like, and now I have a child who is in my clock shift with me. And I'm like, yeah, 13-year-old, you sleep till noon. Go do that. Get your sleep. It's good for your brain.
Yeah. Yeah. Your brain has to sleep through your teenage years in order to develop.
Did I tell you? I think he's taller than me now.
Oh, wow.
It
Wow.
happened. He growth
Yeah, I've
spurted.
got-
She's like, and
Okay.
his voice is kind of, I don't like, the change is happening. Oh, he's wonderful. He's great. How are y'all out there? Everything good?
One of my boys is I think taller than me now, and one of my girls is almost
Shouldn't
my height now.
How's your boy? Your boy is how old? 20? No, 18? 21?
Much
21.
more. He's got like a wife and kid and a family, and he's been at his job for 10 years.
No. He's 37.
What are you talking about?
Oh dear. Can we all stop aging already? Can we just stop measuring time by orbits around our
a little while ago
plasma ball?
This is too much effort. I'm not seeing the returns from all this aging.
I am still dancing though. And I will say that I have been annoying Marshall more than ever recently. Apparently, your brain stopped aging at 14. Yeah, that totally counts, Paul Disney. For sure. Yeah. Eden TG, thank you for joining us. Good night, Robert Varner. Everyone. Yeah. I started taking these, chewing up these little mushroom gummies every day. Lion's mane, wolf's bane. I don't know. I don't know what's in them, actually. I mean, you never know, right? Because none of it is regulated. I have been a wackadoodle for weeks. I have energy, but I'm a wackadoodle. That's pretty much it.
Yeah. Well, supposedly, yeah.
Eric, congratulations on reaching 11.
Somebody reached 11?
Yeah, Eric Knapp says he started recounting his age when he finished cancer treatment. He's now 11.
Nice.
Which I think that's amazing.
That's very cool.
Yeah. Maybe I'll go backwards. I'm going to start counting backwards. That's what my grandmother did. I think it's laudable.
Yeah, I guess grandmother. One of my grandmothers. If you go back and look at the census data, whenever she reported her age, it seems like even though the census is every 10 years, that we come
her age
around.
Stayed the same?
No, it didn't stay the same, but it didn't grow by 10 years. It grew by
That's not right.
She aged 7 years for every 10 years of census. It was pretty interesting. It's like, Grandma, who are you fooling?
Who? What?
You're telling the census. They don't care. They're not trying to date you. And the only people who are going to see this are your grandchildren when all these records that they get looked at from one of those ancestry things, and they're going to go, huh, man, Grandma's a liar. That's all they're going to see.
No. Not a liar. Just exaggerating. Just exaggerating the speed of time. I mean, really, if we counted age based on, say, I don't know, Mars's transit around the sun, right? As opposed to Earth's. Why don't we do that? It's a longer year.
Yeah. Okay. We're all younger on Mars. Is that what you're saying?
Yeah, I mean, 13 years is one orbit for Jupiter. I'm not going to do a leap year. I'm going to do a Jupiter year from now on. Why
Okay,
not?
I gotta go. I gotta run.
Okay,
I
you
will
don't
see you
have work
next week.
today, which is great, but you do, but
Don't.
just not right
I
now.
don't have work. I don't have train catch to work, but I have things I need to do, of course.
There's always. Thanks. Have a wonderful week.
You
Stay
too.
safe,
I will
stay
see you
healthy. You'll see me next week?
next week.
Good. Not this week again?
I guess it's this your week, but it's still next my week. Does that
Yeah.
make sense? Yeah.
It makes sense. Everyone out there, I don't know how the COVID's doing where you are, but it's on the uptick in the western states and a bunch here. So we got our summertime peak. Everybody, stay safe. If you're not feeling well, don't go out. Wear a mask. Be good, please. Let's all try and take care of each other. Let's try and all be tractor beams of hope. Okay? Let's do that. I like it. Stay safe, stay healthy, stay curious, and of course, take a walk in the sunshine with Justin and stay lucky. Bye, everybody.